Session 9.4 Two Variance or Standard Deviation. These sessions, we are working on the hypothesis testing for two populations of two variance or standard deviation. And we were using the F distribution. We call this as the F test for the hypothesis test with the two variance or standard deviation. Requirement: the two populations are independent and has to be simple random samples. And each of the population must be normally distributed regardless of the sample size. So I don't care about the sample size is greater than 30 or less than 30, but the original population must be normally distributed. Okay, notation. Okay, you can see all this notation. That's a 1 in here, okay? S1, N1, sigma 1. This means all this notation is for the population 1 here. And then the first guy, S squared, that is your sample variance. And for the F distribution, you have to choose the larger of the two sample variance as your population 1. That means when you look at two data of the two populations, first, you're going to look at the sample variance. Which one is going to be the larger one? The larger one will be your population 1. And then another one will be your population 2. Okay, and N, that's a sample size. And this is going to be your population variance. Okay, properties of the F distribution. The F distribution is not symmetric. It's going to be skewed to the right. Means like the white tail is longer, just like the chi-square distribution. And the values of the F distribution cannot be negative. Okay, same idea has the chi-square distribution. They're starting from 0 and the number is going to be increasing. So they never have negative numbers. And the exact shape of the F distribution depends on the two different degrees of freedom. So look at this picture. This is your F distribution. First, skew to the right means white tail is longer. Cannot be negative because they're starting from 0 and it's a 1, 2, 3, 4 and so on here. So they never have negative numbers. And then they say F distribution, the shape depends on the two different degrees of freedom. If you guys using the table, okay, the F distribution table, you need to find the degree of freedoms for the numerator and the degree of freedom of denominator. But since we're using the calculator, so we don't really care about the degree of freedom. Okay, but the changing of the degree of freedom, it will be changing the shape of the F distribution. Okay, procedure for testing hypothesis for two population variance or standard deviation. So first, state the null and alternate hypothesis. Okay, null hypothesis is always equal. Alternate hypothesis can be less than, greater than, or not equal to. But pay attention here. Even though we do have the less than, we're still using the white tail. Okay, greater than is the white tail. And then not equal to, that'll be two tails. So that's, we don't have the left tail test in here, okay? We could say this is one tail or two tail. And this is the formula for the test statistic. You can see F distribution equal to the sample variance for the population 1 over the sample variance of the population 2. And remind you guys again, okay? The population 1 has to be the larger of the two sample variance. Okay, this one, the numerator has to be the greater than the denominator. And the test statistic never been less than 1. Okay, cannot be less than 1 because the numerator is greater than the denominator and cannot be negative. Okay, because variance is always positive number. Okay, step 3. Find the p-values and interpret the p-value. You guys can use the calculator for this part. And then at the end, state the conclusion. Again, you can look at the session 8.1, that's a table, right? Remember the number 1, 2, 3, 4 conclusion, you still can use the 4 conclusion. Okay, this is the procedure, how you use the TI 83 and 84 parts to perform the hypothesis testing for 2 variance or standard deviation. We're going to cover this part after the example 1. Okay, example 1. In a series of experiments to determine the absorption rate of pesticides into skin, 2 pesticides were applied to several skin specimens. After a time, the amounts absorbed were measured. Assume that for each pesticide, the amounts absorbed are a simple random sample from a normal population. Can we conclude that the standard deviation of the amount absorbed is greater for pesticide B than for pesticide A? Use the 0.05 significance level. And then they given the sample size and each sample variance here. So first, check the requirement. We do have the simple random sample and the original population is normal. Okay, so we fulfill the requirement. Then we're gonna state the null and alternate hypothesis. But before we state the null and alternate hypothesis, we need to know which one is gonna be your population 1, which one is gonna be your population 2. Okay? So in order to be a population 1, we need to compare the sample variance. Which one is greater? Okay, the greater the sample variance, that would be your population 1. So this guy, the pesticide B, that would be your population 1. And the pesticide A, that would be your population 2. Okay, write it down. Which one is the population 1? Which one is your population 2 first? And then we need to know, are we working on the standard deviation or are we working on the variance? So look at the claim statement. Can we conclude that the standard deviation of the amount absorbed is greater for pesticide B than for pesticide A? So we know we are working on standard deviation, okay? And then we want to know, is the pesticide B greater than for the pesticide A? So first, the null hypothesis, they are equal. An alternate hypothesis, that will be the population 1, which is the pesticide B, greater than the pesticide A, which is the population 2. And write it down, that will be the whitetail test. Okay, remember F distribution, we only have whitetail or two-tail. Okay, B, find the test statistic. This is the formula. We will use the sample variance of population 1 divided by the sample variance of the population 2. Okay, so this is given as the variance. So you guys should get 3.83. Okay, now find the p-value and interpret the result. Okay, you need to use the calculator for this part here. So let's using the calculator. We're gonna go stat, go to the test, go down, you will see, okay, 2 population for the sample F distribution hypothesis testing. They given the statistic, okay? And then this is the standard deviation, okay? Not the variance. But now they given the variance. So we need to do the square root, okay? Square root of 2.3. That will be the standard deviation. And then the sample size is going to be 6. Okay, again, the standard deviation of population 2. So it's going to be square root of 0.6. And then sample size is going to be 10. Okay, we have greater than. And then we're going to choose calculate. Okay, you can see the F distribution, that is a 3.83. This is what we get from the part B. And then they also give you the p-value, okay, 0.03876. Okay, we go back here. So write it down, p-value is going to be 0.0388. And then we're going to interpret the result. Okay, we're going to compare with your significance level. This is a 0.03, this is a 0.05. Should be less than, right? Less than, we're going to reject the hypothesis. Okay, and then state the conclusion. Okay, which conclusion you're going to use? 1, 2, 3, 4. First, the alternate hypothesis is greater than. So we're going to use number 1 or number 2 conclusion. And then we have a reject. So we're going to use the number 1. So that is sufficient evidence to support the claim that, and then you're going to copy this claim statement. The standard deviation of the amount absorbed is greater for pesticides B than for the pesticides A. Example 2. Subjects with a red background were asked to think of creative use for a brick, while other subjects were given the same task with a blue background. Creativity scored response was scored by a panel of judges. Test the claim that those tests with a red background have creativity score with a variation equal to the variation of those tests with a blue background. Use 0.05 significance level. Okay, you guys can see the table here, and they're given the sample size, sample mean, and also the sample standard deviation. Okay, we could check the requirement here. And then A, state the not and alternate hypothesis. Okay, before state that, remember you need to state which one is going to be your population 1, which one is going to be your population 2. So look at the sample variance or standard deviation. Which one is going to be greater? So you could see the red background, this is going to be greater, right? So this one, the red background, will be your population 1. The blue background, that will be your population 2. And then we need to know which one we're going to working on it. It's going to be the standard deviation or the variance. Okay, with the claim statement, test the claim that those tests with a red background have a creative scores with a variation. Okay, this is a variation. So not the standard deviation. We are working on the variance. Okay, so this will be equal, and another alternate hypothesis that will be not equal. And this is gonna be the two-tailed test. Okay, try to find the test statistic using the formula. Okay, you should find the test statistic will be this guy, 2.3706. Okay, pay attention of this guy. This is the sample variance, but here they only give you the sample standard deviation. So you need to use the 0.97 square. Okay, this is a 0.63 square. And then find the p-value and interpret the result. So go to the stat, go to the test, go to 2 sample F distribution hypothesis testing. Then find the statistics summary. Okay, population 1 will be your red background. So this is a standard deviation, so I just put like 0.97. And then sample size 31. Okay, sample standard deviation 0.63. Sample size, that will be 41. And then we have a not equal to. So calculate. So your p-value, that will be 0.0111. Okay, p-value, so it's 0.011. So compare with your significance level, that'll be less than, so it's going to be reject. So conclusion. So we have 1, 2, 3, 4 conclusion. Since alternate hypothesis is not equal to, so we're going to use either number 3 or number 4. And then we have a reject. So we're going to reuse number 3 conclusion. There is sufficient evidence to warrant rejection of the claim that those tests with a red background have a creative scores with a variation equal to the variation for those tests with the blue background. Okay, that's it.